Alright guys, so first I just wanted to tell you that I don't think, or maybe I did send you a message. I think I might have, I can't remember. But I did grade all of your tests. Like I went back and looked at all your scratch work. So whatever is in Alex right now should be like your current course grade so far. Okay, like including the test. So before class ends, I'm going to go back and give you your scratch work, and I'll just let you keep it that way because now the answers like for your test should be visible to you. So if you wanted to like go back and look at anything like with that and use your compare what you put to what the answers were, you'll have your scratch work. Okay, so you can keep it, write on it, whatever you need, and then ask me questions if you have questions about it. Okay, so as a rule in general, you should always check Alex for your course grade rather than Moodle, just because like it's not gonna, even if I would put it into Moodle, it wouldn't be up to date like every day because every time you're working on your homework, it's changing. Okay, so the only time I'll actually put a grade in Moodle is gonna be for like next week. I'll have to put one for midterm, and then like you don't have a midterm, just like what your midterm grade is at the time, and then I'll put it in for the final. But like I'll never go update it on Moodle after I put it in for the midterm. So until the final. So just keep that in mind. Don't refer to Moodle. Look at Alex for your stuff. Okay. All right. And then also for this Saturday, that's like one of our makeup days. You don't have to come to class for that. What I'm gonna do is we're gonna go over section 6.1 and hopefully some of 6.2. And I think I already did this. I'll probably have to push your homework back because your homework, we won't be able to finish all of 6.2. So just for tomorrow, just start like making sure that you are caught up in Alex with where we're at, going over the notes. So that's all I want you to do is just anything that you didn't do so far that's posted, or work on Alex if you need to catch up on that. Okay? Anybody have questions so far? All right. So this first section that I asked you to go over or for us to look at is section 6.1. Okay, and so that section is talking about applications of linear equations. That's mainly what the section's about. But before we get to that, we have to kind of start talking about some things, like some prerequisite things that can maybe help us refresh our memory on equations and things about equations before we get to the part where we're actually going to solve it using word problems. Okay? All right, so the first part that we talked about was order of operations. Okay, so order of operations is basically just a rule or like an order for us. That way, when we solve problems, everybody gets the same answer. So it's just like a set of rules that we have to follow so we can make sure we get the same answer. Okay, and just a little way to help us remember this is PEMDAS. So even though this is like a little hint to help us remember, it's actually not like 100% accurate if you just read it exactly how it is, because it's right that we do need to look at parentheses and exponents first. But then when we get to like the multiplication, division, and addition and subtraction, we do multiplication after or division after exponents, but we do it in the order that we see it in the problem. So like after we evaluate our exponents, if there's like, I don't know, division before multiplication, then we would do that first. Okay, and then the same thing for addition and subtraction. We just kind of have to like read the problem and see how it's set up. Okay, all right, so I did, for the order of operations, I gave you like some 4 little practice questions. So I did number 1 and number 3 with you. Does anybody have questions about 1 or 3? Okay, so let's look at 2 and 4. Did anybody try number 2 that maybe wants to give me an answer that they got? You tried all 3, what'd you get?
I got negative 22.
Very good, you should get negative 22 as the answer for that one. Does anybody need me to go over how we got negative 22? Okay, so what about number 4? Maybe somebody besides Aubrey get number 4. Anybody? You tried it, CJ? What'd you get?
0.7125.
Very good. You should get 0.7125 for that one. Anybody have any questions about how we got that? Okay, so that was the order of operations. I know some of them might be a little bit more tricky in Alex, but hopefully you can use these examples to kind of help you to go through and get those answers for those, okay? And remember, if there ever are any that you're not sure about in Alex, and if you have your laptop or you write it down or something like that, we can always talk about it. You can tell me what it is and we can work it in class if you need to. So just keep that in mind as well, okay? All right. So the next part is evaluating algebraic expressions. Okay, and so for that part, basically I think the hardest part is just being careful that you're plugging in for the correct variable, because sometimes they're going to give you multiple variables to plug in for. So just be careful that you're plugging in for the right letter. Okay, and then after that, you'll just follow order of operations. But remember, for all of these too, you're also going to have your calculator. So if you can ever use your calculator to help you, remember you are allowed to use that. Okay? All right, so I did 1 and 2 with you. Does anybody have questions about 1 or 2? Okay, so let's look at, I'm sorry, I did 1 and 3 with you. Just kidding. I did 1 and 3 with you. So does anybody have questions about those? Okay, so let's look at 2 and 4. Does anybody want to say maybe the answer that they got for number 2? Okay, what'd you get?
11.
11, very good, good job. So you should get 11 for number 2. Anybody have a question about how we get 11? All right, so let's look at number 4. Did anybody else maybe get an answer for number 4? Okay, Katie, what'd you get?
200.
What'd you get?
200.
200? Okay, you're super, super close. I actually got, did somebody get something else? What'd you get, CJ? Yeah, you should get negative 200. So actually, I'm so glad you said that, Katie. Not that you got it wrong, but like I just want to show you where, like probably where you went wrong. So right here, just be careful when you're plugging in. So we want to plug in for k is equal to 3. So we're going to want to plug in like this, and then divide it by 2 times negative 1. Okay, so when we're doing this, remember we're following order of operations, so we're going to want to do the parentheses first. So inside that parentheses, we have negative 10 times 3. So this is going to give us 10 minus 30 squared. And we still have, this is negative 2. So you can do that. This right here is going to give me negative 20. Okay, so if you use your calculator to solve it, which that might be what you did, if you use your calculator, make sure you put a parentheses around, like just like this. Like make sure you type it into your calculator just the way I have it written. Like parentheses, negative 20, close your parentheses, squared. Okay, because if you don't do that, then your calculator is going to think it's like 20 times 20 and then a negative. So then it would be like negative 400 over negative 2, which would give you your positive 200. Okay, but actually, anytime it's squared like this, it's going to end up giving you positive 400 because it's going to be negative 20 times negative 20. And then that's going to be how we get the negative 200. Okay, so just be very careful. Anytime something's squared and it's negative, it's always going to be positive. Okay, so you don't have to do it on your own. You can type it in and just make sure that you put the negative inside the parentheses. Okay, questions about that one? All right. So the next thing, one of almost the last thing of review for you was solving equations. Okay, so I did like the first, I think, 6 of them for you. So does anybody have questions about 1 through 6? Any questions about those? Because especially maybe number 6, because that one was maybe kind of weird. Any questions about those? Okay. Okay, well, so 7 through like 10, basically for equations, I asked you to try. So did anybody get an answer for number 7? You got so Abby? Negative 2, very good. Okay, so Abby got negative 2, that is correct. Does anybody have questions about how we got negative 2? Do we need to work it? Yeah, okay, so let's look at it. Okay, so I'm starting out for number 7. I have 6 parentheses x minus 3 minus 10x equals negative 10. Okay, so that was number 7. So first thing I need to do, I need to be careful, make sure I distribute this 6 to everything in the parentheses. So I'm going to get 6x minus 18 minus 10x equals negative 10. Okay, and so now this is a little bit easier for me to solve because now I just need to look for my like terms. Okay, so my like terms in this problem are going to be 6x and negative 10x. So anytime I have like terms, I'm literally just going to put them together and keep the same sign. So I'm going to say like 6 plus negative 10x or 6 minus 10x. which is going to give me negative 4x minus 18 equals negative 10. Okay, and then I can add 18 to both sides. Okay, and so I'll have negative 4x equals right here. I'm going to subtract, and it's going to stay positive because that one's bigger. Divide by negative 4, and x is going to give me the negative 2. Any questions about that? Is that better? Okay, what about number 8? Maybe somebody besides Abby. Anybody know what number 8 is? Okay, Lashira, right? Am I saying it right? Lashira. Sorry, I keep saying it. Okay, what'd you get? 20? I got something a slight bit different. Anybody get anything else for number 8? What'd you get, Aubrey? I got 5. Okay, so let's look at it. We'll see where we went wrong. Okay, let's see if maybe did you forget to divide it in? Oh, I got a pen right there. Okay, let's see. All right, so for number 8, I have 4, 2x plus 1 equals 29 plus 3 times, I know maybe what might have happened. Okay, so this was a really good one to look at. Okay, so for this one, the first thing we're going to want to do is get rid of those parentheses. Okay, so we're going to want to take this 4 and bring it here, which is going to give us 8x plus 4. And then, okay, can we put this together and then distribute it? No, right? So I don't know if that's what you did, maybe, but what you need to do right here is make sure we do this. So we have to deal with the parentheses first. So this is going to give me this. Okay, so then from here, now I can combine some like terms. I once again have like terms. I have 29 and 15. So now I'll have 8x plus 4 equals, so I'm going to subtract these. So this is going to give me 14 because I don't change the sign or anything. I literally just do like 29 minus 15. And then now I'm almost done. I just have to get variables on one side and numbers on the other side. So it doesn't matter which way I rearrange this as long as that happens. So for me, I like to keep my variable positive. So I'm going to subtract 6x. So I'll end up with 2x plus 4 equals 14. Subtract 4 on each side. And so I'll end up with 2x equals 10. Divide by 2, so x equals 5. Anybody have a question about that? Lashira, do you see where you messed up or no? Okay. Anybody have a question? All right, let's look at number 9. Did anybody get an answer for number 9 maybe that wants to share? You got 140? Yeah, awesome. So young man's right. You should get 140. Anybody need to work that one? Okay, awesome. All right, let's look at number 10, because number 10 maybe I feel like was maybe one of the harder ones on the page that I asked you to do by yourself. Did anybody get an answer for number 10? I mean, we definitely can work that one because that was weird. Anybody? Even if you answered, did you get an answer just so we could see what you got? Did you get some over or no? Because you were like, I don't even know. Okay, just wonder. Nobody wants to share? Okay, well, let's try it then. Are y'all okay with this one? Can I erase this one? We good? All right. Okay, so number 10 says 1/3 n plus 29 over 6 equals 2 times 4/3 n plus 2 over 3. Okay, so for this one, there's several different ways that you could work it. So it kind of is going to be your personal preference. For me, like what I showed you on the video, and for me personally, I find that people make less mistakes when they get rid of the fractions, even though it kind of takes a while for you to get rid of the fractions. So that's the way that I'm going to show you. But remember that you have your calculator. So you could just work the problem like we've been working all the other problems and just use your calculator to deal with the fractions. Or someone in the class that on Wednesday said, well, what if I just turn in all of these into decimals? Could I do that? Yeah, you could just also turn them all into decimals. It's just the only bad part about that is that at the end, when you're going to have to submit it into Alex, you have to make sure that you put it in whatever form they're asking you for. So if they're asking you for a decimal, then it's fine. But if they're asking you for a fraction, which is probably what they'll ask you for because all of this is in fractions, then you need to make sure you know how to turn it back into a fraction, which can all be done on your calculator. Okay. All right. So for me, I would want to multiply by something. So that's the way that I'm going to show you. So what I want to do is look at the denominators. So 3, 6, 3, and 3. I want to look at those denominators, and I want to try to find the smallest number that when I multiply by each of these is going to come out to be like not a decimal. It's going to end up getting rid of the fractions. So basically, I need to think of like, what is the smallest number that I can turn a 3 into, or I can maybe even just leave it as 6 if I need to, or turn a 6 into, like, what number do they have in common? 6, very good. So in this case, I'm going to need to use 6. Now, if you use like 18 or 12, those are all fine because I can obviously turn a 3 into a 12 and a 6 into a 12 and a 3 into an 18 and a 6 into an 18. All those are fine. They're just not the lowest. Okay. All right. So I'm going to take this. I'm going to rewrite it, and I'm going to multiply them all by 6 because not 3. I want to do 6 because 6 is going to divide 3 and 6 evenly. Okay, now this one doesn't have any signs in the middle of this, so I'm just going to multiply it like this. I just need to multiply the 6 to one of the pieces. Okay, and then if I have a calculator, I can use that to kind of help me now. Okay, so I'm going to show you how you can do it on a calculator, but I'll also do it by hand with you. Okay, so in your calculator, you can literally type 6 times 1 ABC3, and that'll give you what it is. Okay, or remember that I wanted these to divide evenly, so I could say, okay, well, 6 divided by 3, that's really 2. So now I have 2 times 1, so that's going to be 2n. Okay, and then this one, of course, 6 divided by 6 is just 1, so 1 times 29 is 29. Okay, or you could do 6 times 29, ABC 6, press enter, and it'll multiply it for you. Okay, now this one I'm going to have to do like a little bit more work. So I'm going to do 6 times 2, that's 12. And then I'm going to keep this right here. And I'm just going to come write it up here for you so you can see. So 2n plus 29. 12. Okay, so what I'm going to want to do is do the same thing I was just doing a while ago. So I'm going to take my 12 and distribute it. So 12 divided by 3 is just going to give me 4. So 4 times 4 is going to give me 16n. Okay, and then the same thing here. 12 divided by 3 is 4. So then 4 times 2 is going to give me 8. And so then now I have this. Okay, and now this is probably a much easier equation for me to solve. Like now this looks a little bit more normal, and so then I can just like work it out. Okay, so again, now I'm at the point where like it doesn't matter which side I bring it to. I just need numbers on one side and variables on the other. So like I told you before, I always like to deal with the variables first, and I like the variables to be positive. So I would just go minus 2n to both sides. So 29, this is going to be 14n plus 8. And then I'm going to take one more step, or 2 more steps. I'm going to subtract 8, and that's going to give me 21 equals 14n. I'm going to divide 14 by both sides, so n equals 21 over 14. Okay, now this kind of brings us to another part that you might have saw on the homework that was, or on the Alex Pod, that was talking about like equivalent fractions. Okay, well, so equivalent fractions are basically just like the reduced form of fractions, right? So this would be an equivalent fraction to, if we divide both of these by 7, so that's 3 over 2. Okay, because these are, they both share a 7. So 3 over 2 is equivalent to 21 over 14. So anytime you're trying to put your answers in Alex, you always want to try to put it in lowest terms. So you would definitely want to put 3 over 2 as your answer. Okay, if you got like 1.5, that would also be correct. Any questions about that one? Okay, so one last thing that's kind of like the review before we get to the word problems. The last thing, and if you looked at the word problems already, you'll kind of see why they gave you this part, is so if you look at 11 and 12, it's just asking you to take equations that have a bunch of variables in them and just rearrange them or solve them for one variable. Okay, and the reason for that is because depending how you set up your equations in the word problem part of your notes, you may need to rearrange an equation to be able to like solve the equations. Okay, so basically all you want to do is whatever letter they're asking you to solve for, you just have to focus on that letter as like being x. And then you just have to get it by itself. Okay. All right, so I did number 11 with you. Does anybody have questions about number 11? Okay, so let's look at number 12. Did anybody get an answer for number 12 that wants to share? I don't know how to do that. You know, Abby, what'd you get?
W equals C over 2H.
Very good. You should get W equals C over 2H. Do we need to do that one? I can show you. Okay, so for this one, it's kind of weird. Let me erase this part right here. Okay, so for number 12, it says C equals 2WH, and it wants you to solve for W. Okay, and again for these, some of the ones on Alex, like they might have more variables, but you just have to remember that whatever variable they're asking you to solve for, that's kind of what you have to like treat as your x. Like that's the thing that you have to get by itself. So do you see that like I want this, so I need to get rid of everything else. So the easiest thing to do is like I need to get rid of this 2, and I need to get rid of this h, and they're all being multiplied by w. So the opposite of multiplication is just division. So I could just divide them, and this is going to cancel. So I'll have W equals C over 2H. Any questions about that one or those? All right, so finally we could get to the part that's actually asking us to solve the problems now, like to actually get to like the application part of it. Okay, so, well, actually we have like one little piece a little bit before that. So if we look at 6.1, like the part where the next part you should see is just like a little table. So this part is going to be like starting finally with the word problem part, which is like what the applications are. Okay, and so if you look at it, you could see like these are just some things to help us when we're going to be reading through the problems to help us to like set up our equation. Now, some of them, the order is not really going to matter. Like for addition and multiplication, it really doesn't matter what order you write it in because they are what we call like commutative, where the order doesn't matter, right? So like, because like 3 plus 4 is 7, and so is 4 plus 3, right? So for those, it's not really important, but for the subtraction and division, you really want to make sure that you write them in the correct order because then it's going to mess up your answer if you don't. Okay, so the first few little questions, we're just asking you a little bit about trying to like apply these, right? Of trying to apply or translate these statements. Okay, so I did 1 through 5 with you. Does anybody have questions about those? Okay, so let's look at number 6. So number 6 says 100 divided by a number. Anybody want to take a guess at how you would write it? Okay, Carissa, what you think?
I can do 100 divided by 8.
Very good. So yeah, you're just going to put 100, the division sign, x. Okay, that's exactly right. Now, in it, Alex, if they ask you to do this, they might ask you to put like n as a variable or something. So just pay attention to whatever variable they're asking you to type in. Okay, very good. Okay, number 7 says 5 more than the product of a number and 7. Anybody want to try that one? Gonna try it, Aubrey? What'd you get?
7x plus 5.
Very good. So 7x plus 5. If you wrote 5 plus 7x, would that be wrong? No, because the order doesn't matter. So you could either write 7x plus 5 or 5 plus 7x. That would mean the exact same thing. Okay, and the reason for that, when you see where it says 5 more, so that means like a plus 5, and then product is meaning multiplication. So 7x and then plus 5. Okay, number 8 says the difference between 25 and a number. Anybody else, maybe besides Carissa and Aubrey, you want to try? So the difference between 25 and a number. I'm going to try, Katie. What you get?
25.
Very good. Okay, so for Katie's example, if she would have put x minus 25, would that be the same thing? No. So for this one, it has to be exactly what Katie said. Has to be 25 minus x because it's subtraction. Okay, so anytime like when it's saying difference, it means subtraction, and then you just write it in the order you see it. So 25 minus x. That's the ones that I feel like are a little tricky because like if it says like I don't know, let's see, like one of them, like a number decreased by 5. I'm just going back to the table. Then it has to be that number and then minus 5. So like just pay attention kind of to the wording of how it's asking you to set it up. Okay. All right, so the very last one, which I think maybe would be the harder one of translating, it says the product of 8 and the difference of a number and 4. Does anybody want to try? Okay, Bree, you want to try it? What you think?
8 parentheses 4 minus 6.
So 8 parentheses what? What was there?
4 minus 5.
Oh, we're super close. Just flip it around. So 8 parentheses. Yeah, x minus 4, n minus 4. So for this one, you should have 8 parentheses, x minus 4, or n minus 4. Because just like the one number 8 that Katie did, see how it says the difference of a number and 4? Just like how it said 25, the difference between 25 and a number. So anytime it's saying like the difference like that, you want to put like literally read it in that order. So a number and 4, so x minus 4, and you want the product of that whole thing. So that's why this one needs a parentheses right there. Good job, Bree. Any questions about those? Okay, so the very last part of this section is talking about the word problems. Finally, I feel like we did all this like reviewing just to get to this. So for these, you're definitely going to want to still try to remember all the stuff that we did from the first test with like Polya's problem solving, where like you can read the question, write down important information, try to do something to solve it. Usually in our case for these is going to be an equation because we're talking about linear equations, and then actually solve it and see if your answer makes sense. Okay, so I did the first one with you, but does anybody have a question about number 1? Or need me to work through it? Okay, so let's look at 2 and 3. So I did number 2 with you, but I didn't do number 3. Does anybody have a question about number 2? Okay, so number 3. Did anybody get an answer for number 3 that they want to maybe share? You want to try, Carissa? What'd you get?
2 plus 5.
2 and 5, very good. Yeah, you should get 2 and 5 as your 2 numbers for number 3. 2 and 5. Do we need to work that one? You might need me to work it for them. I can if you need me to. Are we okay? You might need me to work it? Yeah, I can if you don't need me to. You want me to? Yeah, okay, perfect. So I feel like this is probably the harder part. So if you need me to work them, I can work all the ones that you need me to if you need that. Because that's why we're here. If you need something, I'm definitely willing to work it for you. All right, so for number 3, like I said, like to kind of like, as I go along, I'll like write what I read, right? So the first one says 2 numbers add up to 7. Okay, so I don't know what my 2 numbers are. So I can pick anything as variables to represent those 2 numbers. Maybe like X and Y, A and B, W and K, I don't know, whatever letters you want. Okay, so I just like X and Y. So I know 2 numbers add up to 7. So that's the first thing I would write. X plus Y equals 7. Okay, then I'm going to keep reading. And it says, one number is. Okay, well, so I'm going to pick whichever one of these is my favorite letter. So one of them doesn't matter. So maybe X. So one of them is. So X equals. Then it says half of 5 times another. Okay, so half of 5 times whichever one I didn't pick, Y. So half of 5 times the other one. Okay, then it says, what are the two numbers? So right now I have like too many equations with, like I have 2 equations, but both of them I have 2 things that I don't know, right? But the good thing is one of them is already solved for a variable. So I can use that to help me in the other one. So for example, I know that X is equal to this, right? So instead of X in my problem, I'm literally going to erase X and put what it equals. Well, what does it equal? 1/2 5 times Y. So like go over here and don't write X, write 1/2 5 times Y, but then it's X plus Y equals 7. So plus Y equals 7. Okay, so now I will have all Y's in that equation and I'll be able to get one of the numbers. And then once I get one of those numbers, I'll be able to use it to find the other one. Okay, so here's why I made you do some of those equations with fractions, because now you could just get rid of the fractions to solve the problem. Does anybody know what I would multiply by if I was trying to get rid of the fractions in this equation? 2, very good, because why'd you choose 2, Abby?
This is the only.
Yeah, it's the only denominator, right? So I'm going to multiply all the pieces by 2. Now, see how this has no plus or minus sign in the middle? So I'm going to multiply 2 by this whole thing, 2 by this whole thing, and 2 by this. So every single piece needs to get a 2. Okay, but this is together because it doesn't have a plus or minus sign. Okay, so I'm going to do 2 times 1/2, or 2 divided by 2 is 1. So 1 times 1 is 1. Times 5 is 5Y. Okay, plus 2 times Y equals 7 times 2 is 14. Okay, now this is easier for me to solve, right? I could just combine my like terms. So 7Y equals 14. Divide by 7. So Y is going to give me 2. Okay, so now that's my first number. And now I can just go plug it back into any one of these equations to get my other one. Now, this one's probably not too bad. Like, if you know that they have to equal 7 and you already got 2, you probably know that X is 5 just like by knowing it, right? But for some of them, you might not know. It might not be as easy. So just to remind you, you can go plug that 2 back in here or here. So if you plugged it back in here, you would just do 7 minus 2, which will give me 5. So X is 5 and Y is 2. Okay, and it doesn't matter, like if you got X is 2 and Y is 5, like that doesn't matter if you were like solving it a different way than me. Okay, and then if I plugged it back in here, I could do 5 times 2 is 10, but then half of that is 5. So either one you can plug back in and it'll give you the other number. Questions about that one? Okay, so there are multiple different ways you can do it. Like this is not the only way. This is just the way that made sense to me. So if you see something like I know Alex gives you like some descriptions, or if it says like you can click like help me solve or whatever it is. Like so if you read it and they do it a different way, I don't really care how you do it as long as it's a way that you understand and you can kind of show me how you got it. Any questions about that one? Okay, so let's look at 4 and 5. So I did number 4 with you on the video, but does anybody have a question about number 4? Okay, let's look at number 5. So I didn't do number 5 with you. Did anybody get an answer for number 5, maybe? No? Nobody yet? Nobody got an answer? Okay, well, so I can show you how to work that one because maybe we don't know. Okay, so for number 5, again, as I go, I'm going to just write what I get, like all the information that I'm given. Okay, another thing I like to also do, like if it's possible, so for example, for this one, it's going to be talking about length and width. So like I'm going to choose as my variables like L and W, so that way like I don't get confused, because like sometimes in Alex they might ask you for like just the length or just the width, and if I don't use it, like if I use like X and Y or A and B, I might forget which one I made as the length and which one I made as the width. So it's just easier to use letters that are in the problem. Okay, so it says the length of a rectangle is. So I would write L is. So L equals. Because anytime I have that is, it means equals. So the length of a rectangle is 1 foot less than twice the width. Okay, so it's saying 1 foot less. So less means it's going to be subtraction, right? So I'm going to want twice the width minus 1. Okay. What you think? For the width? So that's the first part, but you gotta find the other one too. But yeah, you're right. The width is definitely 8. Good job. Okay, and so if you put -1 plus 2w for the length, that would also be fine if you wanted to, because it's saying 1 foot less, so the 1 just has to be negative. Okay, then it says the perimeter is 46 feet. Okay, well, so perimeter for a rectangle is 2L plus 2W, because it's just adding all the sides up. Okay, well, we already know that our perimeter in this case is 46. Okay, so now we can go back and use this equation and this equation to help us solve. Okay, so both of these have too many unknowns, right? But this one is already solved for L. So we can come to this equation and say 46 equals, and instead of L, I'm just going to write 2W minus 1. Okay, so I have 2 times L. Okay, but L is this 2W minus 1. So I need a parentheses because it's this whole thing. So I'm just putting this here, but then I still have plus 2W. So I'm still doing 2L plus 2W. It's just that L is 2W minus 1. So I'm going to put it there instead of the L. Okay, then I'm going to distribute. So I'm going to say 4W minus 2 plus 2W equals 46. Okay, and then I'm going to combine my like terms. So 6W minus 2 equals 46. I'm going to add 2 to both sides. So I'm going to get 48 equals 6W. Divide both sides by 6. So W equals 8, like CJ told us a little while ago. Okay, so if they were asking for the width, I could just stop. That would be my answer. If they asked me for the dimensions, like all the dimensions, then I need to go back and find the length. How could I maybe go back and find the length? Plug 8 in. Very good. So any of the boxed in equations, we could just go plug 8 into. Now, usually it's going to be easier to plug it into the one that's already solved. So probably the top one would be easier to plug into, but you could also do the bottom as well. Okay, so if I looked at the top, I would say 2 times 8, so that's just 16, minus 1 would give me 15. So the length would be 15. So I can put an 8 right here. Okay, and I could also put an 8 right here. It's just that I'm going to get 16, then I'm going to have to subtract it from 46, and then I have to divide by 2. So, like, it's just a little bit more steps, but it's not wrong. Okay. Anybody have a question? All right, so the very last one is number 6. Did anybody get an answer for number 6? Anybody? No. No, so I'm gonna look at number 6. Let's go look at number 6. Okay. So number 6. So again, just like last time, I'm gonna use letters that are in the problem, and as I find something, I'm gonna go write it down. Right. So it says a total of $18,000 is invested. Some in stocks, some in bonds. Okay, so that can give me my first equation right there. It says I have $18,000 that is invested. Well, what's that $18,000 made up of? Stocks and bonds. So I'm gonna say S plus B equals 18,000. Stocks plus bonds equals 18,000. Okay, then if I keep reading it, it says, if the amount invested in bonds is, so bonds is, or bonds equals. Okay, again, I think if you read it and stop along the way as you're reading it, it's a little bit better. Okay, so it says, if the amount invested in bonds is half that of stocks, so 1/2 S, half stocks, how much is invested in each category? Okay, so these are my two equations, two things unknown, but I do know what B equals. So instead of B, I'm going to go put 1/2 S. Okay, so I'm going to say stocks plus my bonds is 1/2 S equals 18,000. Okay, so for me, again, I would probably get rid of the fractions. Now, you don't really need to maybe in this one because it's only one fraction, but I just never like to work with fractions, so I probably would get rid of the fractions. So how would I get rid of a fraction? What could I multiply by? 2, very good. And I want to multiply by 2 because that's the only denominator in the problem. So I'm going to do times 2, times 2, times 2. Okay, remember I'm allowed to multiply by whatever I want as long as I do it to all the pieces. Okay, so the first one I'm going to have 2S. The second one I'm going to say 2 times 1/2. So, or 2 divided by 2 is 1. So 1 times 1 is S. So 2S plus S equals 18 times 2 is 36,000. Then now I have an easy equation. I could just combine my terms. So 3S equals 36,000 divided by 3. So S is equal to $12,000. Or 12,000 bonds, is that what it was? Yeah, $12,000. It was dollars. So the stocks is equal 12,000. How can I find the bonds from that?
18,000 minus 12,000.
Very good. So two options. You can either do 18,000 minus 12,000, or you could do 1/2 of 12. So divided by 2. So we would know that my bond is 6,000. So for this one, actually, too, I don't know if this might be harder or not, but you actually could have eliminated the fractions before you even started the problem. Because remember how I was telling you, that's why they made you do that little prerequisite stuff of arranging expressions. Do you see that if I solve this for S, I could just divide all of this by 1/2, or what I could have done is over here, I could have got rid of the fractions by just multiplying by 2. So then I would have had 2B equals S. And so then in the problem, now I would have known what S was. So I could have just put 2B plus B equals 18,000. Does that make sense? If I wanted to. I don't know if that's harder. But you could have rearranged it there, and then that would have given you no fractions here. And then you could have just had 3B equals 18,000, and then you would have divided it, and you would have got the 6,000. You would have got the B first, but it doesn't matter. You could have went and plugged it into anything else. Just like CJ said, oh well, if it's 6,000, just subtract it from 18,000 and get the other answer. So I don't know if that's easier, but that's I think why they were showing you where you could rearrange the expressions, because that might help you sometimes when you're solving a word problem. Okay, so any questions about anything in the 6.1 section about word problems or order of operations or equations? Anything like that? Okay, so we still have a little bit of time, so we're just going to look at a little bit of 6.2. Probably we won't be able to look at that much of it because we're probably going to run out of time. But if you have your 6.2 notes, let's get that out and we're going to look at that. And Carissa. Okay. All right. So 6.2 was mostly just talking about ratios and proportions. So the title includes like ratios, proportions, and variations, but we're just really going to look at ratios and proportions. That's the only thing we're going to need to know for this section. Okay, so the first thing is talking about, the first thing is talking about a ratio. So a ratio is basically just a comparison of two quantities. So it just tells us a little bit more information about two quantities. Okay, so the first, like 1 through 4, is basically just giving us kind of an idea of what a ratio is and helping us to practice like setting up the ratios. Okay, so anytime we have a ratio, we're either going to write it as a fraction or we're going to write it like this with a little colon. Okay, and so that either way, it still represents division, like 1 divided by 2. Okay, so just keep that in mind because Alex should accept it either way unless they tell you specifically that you want to write it a certain way. Okay, all right, so the first one I did with you, it was just asking you to set up a ratio for that question. Anybody have a question about number 1? Okay, so let's look at number 2. So number 2 says from 1969 to 1977, there were 24 teams in Major League Baseball, and only 4 made the playoffs each year. Now, so like today, there are 30 teams and 10 make the playoffs. So it wants us to find the ratio of teams making the playoff to those who don't, and it actually wants us like to have a 2-part answer. It wants us to know in 1969 and today. Okay, so for number 2, it's asking us to find that ratio in 1969 and the same thing today. Okay, so did anybody try it that maybe wants to take a guess? Anybody? No?
4 divided by 2.
What you think it is?
4 divided by 2.
Very good. Okay, so CJ said 4 divided by 20. Okay, so how did you like figure that out?
Because 14 make the playoffs, I subtracted it by 24 months.
Very good. Okay, so he's exactly correct. It says it was the ratio of the teams making the playoffs. So he said, well, it told me 4. Okay, to those who don't. Not to the total teams, it's to those who don't make the playoffs. So if there's 24 teams total and 4 of them made the playoffs, that leaves 20 teams left, 20 minus 4. Okay, now we don't want to leave it like this because this is not our lowest terms, right? So we're going to want to reduce. So these both share a 4, so we can really just say 1/5. So our answer for this first part would be 1/5, or you could say like 1 in 5, like 1 to 5. Okay, what about today? Anybody want to take a guess at that one? So how many teams did it say make the playoffs today? 10. Very good. So we can put 10. Okay, and we don't want. What do you want to put? 20. Very good, because there's 30 teams total. So 10 makes the playoffs already. 30 minus 10 is going to give me 20. So I don't want to leave it like this. I want to write it as an equivalent fraction. So I'm going to put 1/2. Very good, because they can both divide by 10. I could just cancel these zeros. Okay. All right, so because these next 2 are going to kind of like take a little bit, we're just going to stop here because I want to give you back your scratch work. So we'll finish 6.2 when we come back on Friday. So probably, and actually I should have that now, and Alex, I'm going to make your homework due for chapter 6, probably